Hello there.
You are lost in a new city. You open your phone, tap navigate, and instantly you are found. But how does a tiny chip in your phone, thousands of miles from space, know you are standing right here? It is not magic. It is math, timing, and a constellation of satellites working in perfect sync. GPS does not see you. It listens. Your device receives signals from at least 4 satellites orbiting about 12,550 miles above Earth. Each satellite constantly broadcasts 2 things: its exact location in space and the precise time the signal was sent, using atomic clocks accurate to nanoseconds. Your phone calculates distance using a simple formula. Distance equals the speed of light multiplied by the time delay. If a signal takes 0.067 seconds to arrive, you are approximately 12,550 miles from that satellite. Do this with 3 satellites, and you get a 2-dimensional location, latitude and longitude. Add a 4th satellite, and you get altitude, plus a correction for your phone's less accurate internal clock. Why 4 satellites? Because of the clock problem. Satellites have atomic clocks. Your phone has a cheap quartz clock. Even a 1 microsecond error equals a 300-meter location error. The 4th satellite lets your device solve for time as a 4th variable, triangulating position and syncing its clock at the same time. Now, real-world factors affect accuracy. In cities, tall buildings bounce signals, causing location drift. Tree cover or being indoors weakens signals, so your phone uses Wi-Fi or cell towers to assist, a system called assisted GPS. The atmosphere can slow signals, which dual-frequency GPS corrects. And satellite geometry matters. If all visible satellites cluster in one part of the sky, accuracy drops. Modern phones combine GPS with other systems like GLONASS from Russia, Galileo from Europe, and BeiDou from China. This gives your device access to 22 over 100 visible satellites, boosting accuracy to about 1 to 3 meters. Key takeaways. GPS uses trilateration, not triangulation. It uses distance, not angles. Your phone is a receiver only. It does not transmit to satellites. More satellites and better geometry mean higher accuracy. Assisted GPS uses cell or Wi-Fi data to speed up your first location fix. And a privacy note: GPS itself does not track you. Apps do. Turn off location services to opt out. Next time your map app guides you perfectly through a confusing intersection, remember, you are benefiting from a $12 billion US military system, atomic clocks in space, and even Einstein's theory of relativity. Yes, satellite clocks are adjusted for time dilation. All to answer one simple question: where am I? Did you know GPS was originally military only? When do you rely on it most? Driving, hiking, or just finding coffee? Let me know. And if you found this helpful, subscribe for more tech explainers that turn complex into clear.